Hi, I'm Blake Parrish, and my project is about 5-class sentiment classification of tweets with distant supervision. The motivation for this project comes from research done by a group of Stanford students in 2009. This group used the inclusion of positive and negative emojis and tweets scraped from Twitter as a form of noisy labeling for training data. Using logistic regression and naive Bayes models trained on this dataset, along with unigram and bigram features, they were able to achieve accuracies of around 80% when testing on randomly sampled hand-labeled tweets. The goal of this project is to extend this noisy labeling technique from a binary classification task to a sentiment classification task with 5 classes. This will hopefully make it possible to gain more information about the sentiment of a tweet by allowing tweets to be bucketed into very negative, negative, neutral, positive, and very positive classes. I obtained the dataset for this project using the Twitter API to scrape tweets containing at least one positive or negative emoji. In order to obtain data relevant for extreme sentiment classification, this scraping technique put an extra emphasis on tweets with multiple emojis, allowing for combinations of positive and negative emojis. The pre-processing of the training tweets included normalization of the tokens, along with the removal of emojis entirely. The sentiment of these tweets was determined by the difference in counts of positive and negative emojis with a cap at a difference of 2, giving them scores ranging from -2 to 2. The test and dev sets were obtained by scraping Twitter with pseudo-random queries. These tweets didn't necessarily contain any emojis. These 500 or so tweets were then hand-labeled, also with sentiment scores ranging from -2 to 2. For a baseline model, I chose to classify tweets based on the sentiment of the words in the tweet, according to the NLTK opinion lexicon. Similarly to how the training data was labeled, sentiment scores were determined by the difference in counts of positive and negative words included in the tweet, with a cap at 2 and -2. This baseline model achieved a classification accuracy of 46.2%. For the time being, my model testing has been confined to listed regression classifiers. Using unigram features, this model achieved an accuracy of 34.4%. By filtering unigrams on words included in the opinion lexicon, this accuracy rose to 39.9%. When filtering unigrams on words included in the English dictionary, the model was 36% accurate. These accuracies were much lower than the baseline model, mostly due to the fact that the model was almost never able to correctly classify very positive or very negative tweets. In an effort to remedy this problem, I plan on rescraping and relabeling the test and dev sets, throwing out tweets without clear sentiment subjects. I also plan to begin including both bigram and unigram features. Finally, I also plan on scraping additional training tweets. The current dataset has hundreds of thousands of examples, but could definitely be expanded upon.